Hello my dear students, welcome back to NEET World. So today we will be discussing P block elements. Okay, so I hope you are following our sessions for this IPE sessions right now. So we are conducting this free IPE sessions for both class 11th as well as class 12th for both Telangana and AP students. First year students and second year students, for both Telangana and AP students can utilize these classes for making their IP preparation more effective. See, many of the students are searching for important questions and explanation of those important questions right now. So they are struggling too much. So to avoid all this and to make the preparation very easy for all the students, see, we are conducting these free live sessions using our C60 modules. So what is this C60 modules? So these modules contain all the important questions. Okay. So in the market, we are not having proper materials for IP students. Most of the students are suffering with that right now, struggling with that. So we are bringing up this C60 module. So this C60 indicates what? Chemistry. In chemistry you can able to score maximum like 60 out of 60 marks with these modules. Okay, so this will be available for both first year and second year students. Okay, so all the Telugu state students can download these modules at free of cost from our app. What is our app here? So NEET World app. And you know guys, these modules, I mean these booklets are also available. Soon it will be available in the nearest stores. I mean, if you are from Hyderabad, yes, these books are available nearest stores in famous bookstalls also very soon. Okay, and you can order these books from our side also. But if you want for free of cost, you are unable to bear this cost also, like minimal charge also. Just download this NEET World app from Play Store and you can access complete soft copy of this book. Okay, not only chemistry, yes, so along with chemistry you have physics as well as biologies also, like botany, zoology, and along with that you can also access mathematics. If you are an MPC students, 1A 1B books are also available. Okay, so all these books are very neatly framed, so you can utilize these books and you can make your preparation more effective. And guys, those students, like those friends, like you might be having so many friends who are looking for books or study materials or the explanation of each and every question right now, because most of them are struggling to get the answers, like they have like many struggles while like learning the questions right now. So to avoid all those things, we are coming up with a free live explanation. It means we are providing free material for their preparation along with each one-on-one explanation itself right now. So each question will be discussed in detail with proper answer. Okay, so you just make your answer from these booklets if you are watching only live sessions, and you can use that answer for your final examination. That's it. Okay, right. So in the last session I have covered electrochemistry and chemical kinetics. What I have covered? Electrochemistry and chemical kinetics for class 12 students, whereas class 11 students I have covered structure of atom, classification of elements, and organic chemistry also few questions are covered. For both of them are these LAQ sessions are going on now. As of now, LAQ questions are under discussion. So once after finishing these LAQs, we will be looking into the SAQs also, then after very short answer type questions also. So everything will be clearly explained. The only thing you need to do is just click on the like button and just click on the follow button. If you are new to this channel, just click on the subscribe button and stay connected with our channel. Okay, so complete afternoon sessions from our side will be focused only on IP session. If you have seen today, so from the afternoon, after lunch time to till evening 7:30 we are focusing, or 6:30 to 7:30 we will be focusing only on IP sessions. Okay, so most of the students are staying only at home because in every college, whether it is government or private, whether you are from urban, rural, anywhere, all the colleges might completed their syllabus and they have given this time for their preparation, like revision time or preparation holidays right now. So now you can use this time and you can score very good marks. So why I am stressing this much? Because you can use your IPE marks. You can, there are some institutes can provide free seats or the reduction in the fees you based on your IPE marks. They can provide some scholarships based on your IPE marks. Okay, so that's why I suggest you to get a maximum score in your IPE exams. Do not ignore them. Okay, and most of the second year students, చాలా మంది second year students are వాళ్ళు ఎలా ఉన్నారనంటే ఇప్పుడు వాళ్ళు జేఈ ప్రిపరేషన్ బిజీలో ఉండుంటారు కదా. సో ఈ జేఈ ప్రిపరేషన్ బిజీలో do not ignore your IPE also, because exams are very close, JEE and IPE. See, if you are a really serious aspirant of your JEE, so just when you are studying for JEE, for example, I will tell you one simple suggestion. See, if you are studying for SN2 reaction, SN1 reaction, otherwise haloalkanes chapter you are studying. Okay, so in this, when you are preparing for SN1, SN2 reaction, application, see, JEE means application based questions right now. So now you just study SN1, SN2 reaction, SN1 and SN2 reaction. That is very very important for your IPE exam right now. So you just study this SN1, SN2 reaction theoretical way, which will be helpful for your IPE preparation right now. So once after doing this, just the application of this SN1, SN2 reactions only, that questions comes in your JEE right now. So this is how you can make your preparation productive and more effective, and simultaneously you can cover both IPE and your JEE. Therefore there is no fear of failure or something like that. Okay, yes, so handle everything in a with a proper plan and make your preparation more productive and more effective. That's it. Okay, so this is from my side, and today's session is on P block element. On what? P block elements. So we will be discussing about P block elements. Okay, so from P block elements we can expect a 8 marks question right now. So this 8 marks questions we are going to cover in this session. Okay, so for electrochemistry already covered, and if you haven't watched, you can watch the electrochemistry explanation questions in the live sessions in the playlist of this channel itself. Okay, right, let me discuss this. See what they are asking here. I hope you are seeing this, whatever the PDF I am sharing here is clearly visible, whatever the notes I am sharing here is clearly visible right now, right? Right, is there any issue in the audio or video? No, right, everything is clear, right? Yes, please mention those who are in the live session. Yes, those who are in the live session, please respond on time, so that it will be more like, you know, it will be two-sided. See here, I think it is very clearly visible to everyone. Right, read the question once. How is ozone prepared from oxygen? Explain its reaction with these 4 compounds. What are the 4 compounds? Ethylene, Ki, potassium iodide, mercury, lead sulfide and silver. Okay, this is the first question they have given. Okay, so now, and you know this guys, this book is our book only. So if you download NEET World app, if you download this NEET World app, so this book is available in this app. Okay, it will be there in this app. Just download this app, this NEET World app, and you can access this. And whenever I am reading that, just open the PDF and just go through line by line, so that everything will be comes into your mind, and that will be more effective for your preparation. See here, preparation of ozone. What they are saying? Ozone is prepared when pure dry gas is passed through a silent electric discharge. So it means ozone is prepared by, how it will be prepared? Like oxygen gas will be passed through electric discharge tube, we can say. Okay, electric discharge, and it will be giving us O3. Oxygen will be converted into O3. So this one, see 3O2 is there, just balance the equation. Now it becomes a 2O3. That's it. That's it. So where it will be happen? In discharge tube. Okay, that's it. So using an so what is the operator we will be using for this process? The operator used is called ozonizer. What is that operator called? Ozonizer. Okay, yes. Ansar Nazir. Clear. Sir, ye daily hoga? Yes. See, dear Ansar Nazir, yes, these sessions are conducted every day regularly in the afternoon sessions. Okay, in the morning sessions you will be having EAP set discussion like MSET or EAP set discussions will be there. EAP set live sessions are going at morning, and afternoon sessions completely for IP. So just come access all these free live sessions. See guys, this is this is not for namesake. We are providing very quality lecture notes, I mean these PDF notes that will be useful for your IPE presentation itself. Okay, so just use them very effectively and make it more productive preparation. Okay, please share with your friends those who are preparing for IPE exam. Okay, so more the support you show, the more productive it will be, like the more things we can offer for you in the live sessions itself. Okay, so just look at here what I am saying. Next, what is the first method? Oxygen upon passing through electric discharge tube, it will be converted into ozone. Okay, O2 is converting into O3, that's it. So where it happens? In an apparatus called ozonizer. So what is that called? Ozone is prepared when pure dry oxygen is passed through a electric discharge using apparatus called ozonizer. In where it is? Ozonizer. But you know, very small portion of oxygen get converted into ozone. Okay, so if you send 100%, it will be only 10%. Out of 100%, only 10% of oxygen is converted into ozone form. Okay, so the mixture containing ozone, so the mixture whatever we are getting, that mixture is called ozonized oxygen. What is it called? Ozonized oxygen. So during this process, it is an endothermic process. So this much amount of energy is absorbed. How much? Delta H, standard enthalpy, is given as plus 142 kilojoule per mole. This much amount of energy is absorbed during this conversion of oxygen to ozone. Remember this. Okay, and after this what we have, just check here. So chemical reactions of ozone. So how this ozone is showing its chemical reaction. Okay, this is very easy, and you know the same reaction you have did in your first year also in hydrocarbons. Okay, anyways, I will be explaining here. Just look at here what they are saying. Reaction with ethylene. What they are saying? Reaction with ethylene. What is the formula of ethylene? C2H4, right? Now C2H4. So this C2H4 you can also write it as CHH, like this. C2H4 means you can write it like this. Okay, so now this ethylene reacts with ozone. So ozone is reacting with ethylene. Okay, so this will be forming ethylene ozonide. What they will forming? Such intermediate is formed. That intermediate is called ethylene ozonide. Okay, ethylene ozonide. It means nothing. Just break these bonds, these two bonds. Just I am writing ozone here very clearly. Positive charge here, negative charge here. Like this you need to write the ozone. Now what happens is, between these carbons and this ozone, reaction takes place. See, this negative charge will be donated to the carbon, and this pi electrons is given to the oxygen, and this will be shifting like this. So like this we are going to get a malozonide that will be get rearranges to ozonide. So directly, no need of writing mechanism in your exam, directly you can write the answer here. So it will be connected to two oxygen atoms like this, and one oxygen in between, and two hydrogens like this. Okay, like this. So this is called ozonide. What I am saying, this is called ozonide. So this ozonide, this is a forms like an intermediate. Okay, so this ozonide, upon treating with zinc, with what? We need to treat this with zinc in water. So now what happens is, it will be breaks into two equal halves. Okay, so how it will be? It will be breaking into two equal halves like this. So very simple guys, I will tell you one simple trick to write the product. But if you directly write the product, examine like paper correction, the person who is giving you the marks, he will not give full marks when you write directly. So try to elaborate it as much as you can. Okay, with a proper way. Okay, so that here breaking the bonds now. So you can write C double bond O and hydrogen here, like this side one and this side one. You are going to get 2 moles of formaldehyde and 1 mole of this oxygen with zinc oxide will be formed. Okay, now look, now just look here, what is happening here? See, the product formed is nothing but you are breaking this molecule into 2 equal halves like this. What is this equal halves means? Ethylene now. So just break into 2 equal halves, so that you will get C hydrogen like this, and after breaking just insert 1 oxygen, this side 1 oxygen, and for this carbon also you insert 1 more oxygen. That's it. You are going to get 2 moles of formaldehydes. What we are going to get? 2 moles of formaldehydes we are going to get. Okay, so this is the way you need to get the answer. Okay, is this clear, guys? Is this clear? If this is clear, just click on the like button. What I am saying, so whenever they are asking chemical reaction of ozone, okay, chemical reaction of ozone with ethylene, just write the structure of ethylene like this. After writing, see, I am giving you a simple trick. After writing this, just break this double bond, insert one oxygen this side and one more on this side, that's it. So what you are going to get? CH, carbon is there, what I told you, just break the double bond. After breaking, what I told you, just insert this oxygen. Yes, inserted, oxygen is inserted. Similarly, this side also place CH, insert one more oxygen this side, that's it, like this, that's it. These are the products form. Both of them are same only now. So the name of this compound is called formaldehyde. What you can call? Formaldehyde. So one molecule of this alkene, one molecule of this ethylene giving 2 moles of formaldehyde. I mean, one molecule of this alkene giving 2 molecules of this formaldehyde. That's it. This is how you need to present in your exam. That's it. Okay. So if you represent this ozonide as an intermediate, yes, it is really good because he will give full marks. Okay, right. Then next, reaction with Ki. What is that? Reaction with potassium iodide. Potassium iodide to ozone ela react avutundi ani cheptunnaru. So very easy, look at here. Ozone, it means O3. So O3 is unstable. Okay, O3 oxidizes moisture potassium iodide to iodine. What it will be doing? Ki iodide, potassium iodide, Ki will be K plus I minus, will be get oxidized when we treat this with ozone. So you can say ozone act as a good oxidizing agent because O3 will be little unstable form of ozone, I mean oxygen. So that's why ozone, whenever it is reacting with some species, it will try to act as oxidizing agent and gives its oxygen, therefore it becomes O2. So O3 by giving oxygen out, it will be converts into O2 and one oxygen will be coming out. So due to liberation of, like if it is removing one oxygen, it will become O2. It is a stable species, no? That's why ozone shows its oxidizing nature. What it will shows? Oxidizing nature. So here you can see ozone is oxidizing. See, ozone oxidizes moisture potassium iodide. What it will do? It will oxidizes moisture potassium iodide to iodine. So iodide ion I minus is converting into I2 and now O3 is converting into O2. That's it. Okay, and here K plus is there now, that you can write it as KOH you can write. So 2 Ki is there, 2 KOH you can write. That's it. So just look at the reaction, whatever we have written, so that will be the thing they have given. Okay, that's it. Is this clear or not? Yes guys, those who are clear with the concept, please click on the like button. And also mention if it is clear, just mention clear. If it is not clear, feel free to ask me once again. I am going to say you. I will be explaining it once again. If you just mention in the chat box, based on your response, I am going to react on this. That's it. Okay. So just tell me third reaction here mentioned as ozone reaction with mercury. What is that? Reaction of ozone with mercury. Okay. So it is very simple. Look at here. Ozone, here also ozone acts as oxidizing agent only. So ozone oxidizes metallic mercury. What it will be doing? Oxidizing metallic mercury. Mercury means Hg, right? So this Hg will get oxidized by our ozone to mercurous oxide, Hg2O. For this purpose you require 2 mercuries. Okay, mercury atomic form. So it is forming +1 oxidation state here. So if we remove one oxygen from here, remaining part is how much? O2. That's it. This is the product form. Okay. So this is third reaction. First reaction is ozonolysis. Ozonolysis of alkene, that is ethene, and the next reaction is reaction of ozone with Ki, and the next reaction of ozone with Hg. 3 things are over. All 3 things are very simple and very easy, right? So hope everything that we discussed till now are clear. Yes guys, those who are saying clear, please mention clear. Next Next, reaction with PBS, lead sulfide. What is that? Lead sulfide. So look at this, what they are saying. Ozone, again here also oxidizing agent only. Ozone oxidizes black lead sulfide to white lead sulfate. Where to where? Black lead sulfide. So sulfide here, PBS is there now. So this is black color compound with sulfur -2 charge, lead +2 charge. Will be get oxidizes to sulfate. What I am saying? Sulfate. So it will be PbSO4 sulfate here. It is +6 oxidation state, here -2 oxidation state. Sulfide is converting into sulfate. Okay, so it means oxygen gas will be released. See how many oxygens we added to this sulfur? 4 oxygens now. So each ozone will be giving us 1 oxygen atom. Like that we required 4 oxygen atoms. It means you just need to add 4 ozones. So 4O3. So from this 4O3 you are removing 1 oxygen atom each time. Therefore you will be having O2s. How many O2s? 4 O2s will be there. So plus 4 O2 will be produced. That's it. So this is how you need to understand the thing, understand the chemical reaction. Clear now? Yes guys, I hope this is also clear. Next, what they are saying? Reaction of silver with ozone. So again ozone oxidizes silver metal to its metal oxide. So what is its metal oxide? Silver will be in +1 oxidation state. When it is undergoing reaction, it will be showing +1 oxidation state. So you can see here silver plus O3. Again O3 will give oxygen atom now. So 1 oxygen atom have -2 charge. So but silver will be having only +1. So completely to neutralize this, so 2 silver atoms are required. That's why 2Ag plus O3 giving rise to Ag2O plus O2. That's it. This is how you need to write the reaction. Clear kada? Ardhamainda? So what I am saying, once again silver atom అనేది +1 ఆక్సిడేషన్ స్టేట్ చూపిస్తుంది. సో బట్ ఇక్కడ ఆక్సిజన్ ఆటమ్ వస్తుంది కదా ఓజోన్ లో నుంచి. ఎప్పుడు కానీ ఆక్సిజన్ ఆటమ్ మీద మెటల్స్ రియాక్ట్ అయినప్పుడు -2 చార్జ్ ఉంటుంది, అంటే ఆక్సైడ్ ఫామ్ లో ఉంటుంది. సో ఆక్సైడ్ ఫామ్ లో అంటే O-2 లాగా ఉంటుంది. సో ఇది -2 అయితే సిల్వర్ ఒక్కొక్కటి +1 లాగా ఉంటుంది. సో అలాంటివి ఎన్ని సిల్వర్స్ కావాలి? 2. సో దట్స్ వై వీఆర్ టేకింగ్ 2 సిల్వర్ ఆటమ్స్ ప్లస్ O3 గివింగ్ రైస్ టు Ag2O2. Ag2O plus O2. That's it. This is what the reaction mentioned here. So hope everything is clear whatever we discussed. Right. Next one, up to here first question is done. First 8 marks question is done from P block, right? Next 8 marks question here is how ammonia is manufactured by Haber's process. Okay, ammonia ni Haber's process ద్వారా ఎలా తయారు చేస్తామని అడుగుతున్నారు. It is very easy. Explain the reactions of ammonia with zinc sulfate, copper sulfate and silver chloride. Zinc sulfate, copper sulfate and silver chloride. Very easy. Just follow my explanation. What I am saying here. See here what they are saying. Manufacturing of ammonia using Haber's process. What is that process called? Haber's process. So in Haber's process is an important industrial method used to manufacture ammonia by direct combination of nitrogen gas with hydrogen gas. Okay, ante Haber's process is a process which is used in the industrial preparation of ammonia. So in industrial production, ammonia can be prepared by this Haber's process. Okay, so what they will be using, the raw material here they will be using is nitrogen gas plus hydrogen gas. What is that? Nitrogen gas plus hydrogen gas combines to give ammonia. So the combination of nitrogen and hydrogen gas produces ammonia, NH3. So this reaction is a reversible process. What is this? Reversible process. That's why if you see the arrow mark mentioned here is in equilibrium symbol. Okay, and the next, this reaction is an exothermic. What I am saying, this reaction is reversible and it is exothermic and proceeds, it means the reaction proceeds with a decrease in volume. With what happening? With a decrease in volume, reaction proceeds forward. Okay, so it means formation of ammonia proceeds forward with a decrease in volume. Okay, and what are the 3 things mentioned? Reaction is equilibrium, reaction is in equilibrium, that is in reversible reaction, so there may exist equilibrium. Okay, so in order to make this reaction to move forward, so low volume, like decrease in volume should be favoring, and it is an exothermic reaction. It means during the reaction heat is released. How much? Minus 92 kilojoules is released. So it means heat is released for forward reaction, means low temperatures favors this forward direction of this ammonia production. Okay, right. So the reaction occurs in the presence of finely divided iron catalyst. So what is the catalyst used here? Iron, Fe, and there is a co-catalyst also, molybdenum as a promoter. So what is this co-catalyst? Promoter here is molybdenum. So molybdenum as a promoter. Okay, so need to use, what to use here? Catalyst is iron and promoter is molybdenum. Okay, then next. So what is the optimum pressure and temperature mentioned here? These are the specific industrial method now. So in the during industrial method, this much temperature should be maintained and this much pressure should be maintained. How much? 725 to 775 Kelvin temperature plus 200 atm high pressures are required here. 200 atm pressures are required. Okay, so high pressure like 200 atm pressure. So 200 atm pressure should be maintained during the process, and 775 Kelvin temperature should be maintained. 725 to 775 Kelvin temperature is maintained. That's it. Okay, clear now? Next look at the next statement. What they are saying? According to Le-Chatelier principle, what are the favorable conditions? Why this Le-Chatelier principle came here? Very simple. Write the reaction here. N2 plus H2 gives rise to NH3 we are writing right now. So now just try to balance this. 1 N2 plus 3 H2 gives 2 NH3 like this. See what is the symbol I am using here? Equilibrium, like reversible reaction symbol I am using. So this symbol indicates that reaction may favor backward, reaction may favor forward. It is an equilibrium reaction symbol. Okay, if they are with equal values, equal arrow marks, I mean with equal extent, then you can say reaction is at equilibrium. Now this equilibrium reaction either goes backward or forward depending upon the conditions we are maintaining during the reaction. Okay, so it means what we required, we need to produce ammonia gas right now, product should be formed. So it means equilibrium should move forward. So what are the favorable conditions that are making reaction to move forward? That is what we are studying now. See, moderately low temperature, moderately low, how much? 450 to 500 degrees Celsius is used because low temperature favors forward reaction. Low temperature slows down the reaction and high temperature reduces the yield. So to produce ammonia, we need to maintain moderately low temperatures because reaction is exothermic now. So these exothermic reactions are favored by lower temperatures. Okay, so moderately lower temperatures are used for production of ammonia. Temperature condition is what? Moderately low, and you can, if you want, you can mention that optimum condition, that is how much? 725 to 725 to 775 Kelvin temperature you can mention in the bracket. Okay, and the next, what about pressure conditions? What about pressure conditions? See, high pressures how much? 200 to 900 atm pressure should be used here. How much? Just read the one more statement here. What is the catalyst here? Already we have studied that catalyst. Yes, tell me what is the catalyst here used? See, high pressure. So high pressures, like pressure, how much pressure? 200 to 900 atm pressure is preferred here. That will increases the yield because reaction proceeds with a decrease in volume. So if I increase the pressure, what happens to, if I have a container here, so I'm using a piston here. So if I use the pressure here, if I make it more pressure, volume decreases na? Yes. So volume will be decreased when we increase the pressure. So high pressures and low volumes are the favorable conditions for forward reaction. So reaction favored forward with high pressures, low temperature, like moderately low temperatures and high pressures are used here. Those are the conditions maintained here. Okay. Then next, what is the catalyst used here? Finely divided iron. Okay, iron with a small amount of molybdenum as promoter. What are the things? Iron plus molybdenum. Iron is a catalyst, molybdenum is a promoter. Okay, these are the things you should maintain or you should mention. Okay, and then next, industrial catalyst may contain some alumina Al2O3 and some potassium dioxide. Okay, potassium oxide K2O3, potassium oxide for stability. So what are the things you need to write during the exam? You need to write iron as a catalyst, and molybdenum as a promoter, and along with this some traces of Al2O3 and K2O for stability. For what? For stability. Okay. So this is a mixture will be used for during this process. Okay. Now this is an experimental setup. So I hope it is clearly visible to everyone. What is the experimental setup mentioned here? So just look into the representation what they are mentioned here. See, from this side H2 gas, from here H2 gas and N2 gas is passed. Okay. So these are the starting materials right now. So from this H2 gas and N2 gas is passed. So that will be enters into compressor. Okay. At compressor this is a 20 mega, like 20 M pascals, like that much pressure should be maintained. Okay. So now this will be comes into this bar. What is this? Here catalyst iron oxide, aluminium plus K2O is there. So this is at 720 or 700 Kelvin temperature. Okay. So now after this, from here that mixture slowly starting reaction, like here reaction starts and it will be forming ammonia. So whatever the ammonia formed with high pressure, this is coming into this collector here. Okay. So here liquid ammonia is collected. Now during the reaction, see, during the reaction some amount of N2H2 will remain unreacted, that will also come from this. So because N2 gas is very stable now, that's why sometimes it has more escaping tendency, it will come along with ammonia formation. So here whatever the extra ammonia, extra N2 or H2 is coming, that will be taken into this tube, again that will be sent backward, that will again come back to here compressor, again the same process will be taking place, again it will be coming this side, going again on this catalyst, again comes and gives ammonia. So this is a repetitive process like this. Okay, right. Okay. So now what happens in the compressor? A mixture of, in the compressor we will be passing mixture of nitrogen gas and mixture of nitrogen and hydrogen in 1:3 ratio is compressed at what temperature? 200 to, at what pressure? 200 to 900 atm pressure it will be compressed. Okay, very high pressures it is. Then next, ammonia converter, that is catalyst chamber. So here only ammonia will be forming. See, compressed gases are heated at 450 to 500 Kelvin, 500 degrees, 450 to 500 degrees, and passed over iron catalyst. What they will be doing? They will be passed over So now what I am saying, the compressed gas heated to 450 to 500 degrees Celsius, and now this is passed over iron catalyst containing molybdenum. So what is that? Along with iron we have molybdenum catalyst. Okay, molybdenum promoter. Okay, so now ammonia along with its unreacted N2 and H2 emerges from the chamber. It means it will be compressed here, this H2 and N2 in 1:3 ratio, it will be compressed here. at a pressure of 200 atm to 900 atm, right now. Then that compressed gases will come here into this catalyst chamber. So in this catalyst chamber, like production of ammonia takes place. That ammonia with high pressure is coming this side. So here what happens, along with ammonia, some amount of N2 and H2, unreacted N2 and H2 also comes. So whatever N2, H2 is coming here, that will be again sent backward into this pump, again from this pump to again catalyst chamber, again it will be repeated. Okay. So like this complete compound will be converted into ammonia product. Okay. Okay. So then next look at here, condenser. What we have? Condenser. The mixture is cooled, the liquid ammonia separates out as a liquor ammonia. How it will be? Like liquor, like liquid ammonia will be comes out. Okay. And filled into the cylinders. It will be like ammonia, whatever the liquid ammonia coming out, that will be filled into the cylinders. Okay. Right. Next, circulating pump. There is a pump now, whatever the unreacted N2 and H2 gas are there, that will be sent back to the converter, again like a recycling process we can say, and this will improve the efficiency, that will improve the production of ammonia will be more when we are sending that unreacted nitrogen into the chamber again. So for that purpose we are using this circulating pump. Okay. So everything step by step you need to first represent, like you can give a rough diagram, first giving inlets of N2 and H2. So now this gases mixture in 1:3 compressed in the compressor. At what is the pressure? Please mention the pressure, 200 to 900 atm pressure. Okay. So from this will be passed into the catalyst chamber, where it is catalyst chamber. So from this catalyst chamber the reaction takes place and ammonia formation takes place, that will be passed into the collector. Okay. So it will be collected in a container. Okay. Liquid ammonia will be there. Along with the liquid ammonia, some amount of N2 and H2 gases also comes from this catalyst chamber. So that will be again with the help of the circulating pump, again it will be sent into this catalyst chamber. So this is pump here. So what is the duty of this pump? So pump will be used for recycling. What is that? Recycling of N2, whatever unreacted N2 and H2 is there now, that will be recycled with the help of pump, and that will be sent again to the production process. So with the help of pump we can increase the efficiency of this reaction, this production. Okay. Because it's an industrial method now, so we require in industrial method every process or everything will be used for getting high yield. Okay. Because it is a commercial purpose also right now. So it means it will be it will be produced at a cheaper rate. Okay. So for that they will always think for maximum production. Okay. Maximum efficiency. What is that? Maximum efficiency should be there. That's why the circulating pump is used. The next, drying of ammonia. How ammonia will be dried? So moisture is removed using quicklime. What is the thing they are using? Quicklime. So like calcium oxide. So ammonia cannot be dried using concentrated sulfuric acid or calcium chloride or P4O10, because ammonia react with this reagent. See, ammonia is a basic substance. If we add this like sulfuric acid kind of things, what happens? Simple acid base reaction takes place. So that's why these things are not used here. P4O10, that is also acidic oxide. So there is a acid base reaction. So that's why this sulfuric acid, calcium oxide, calcium chloride or P4O10 cannot be used. Here what they are using? Calcium oxide is used. What is it? Calcium oxide, because calcium oxide is also basic substance now. So basic, ammonia is basic, calcium oxide also basic. So there will not be any reaction as we seen in this case. Okay. That's why calcium quicklime is preferred for hydrating, like drying of this, dehydrating or drying of this ammonia. Okay. Remember. Next, up to here you got to know production of ammonia using Haber's process. What is that process? Industrial method, that is Haber's process. Okay. And the next here we have is their chemical properties. What we have? Chemical properties. Okay. We will discuss chemical properties. Yes, look at here, chemical properties of ammonia. Okay, so what they are saying, reaction with zinc, ammonia reaction with what? Zinc. So how ammonia reacts with zinc, that is what the question they are asking. So ammonia solution reacts with zinc sulfate to form a white precipitate of zinc hydroxide. What it will be forming? Zinc hydroxide and ammonium sulfate. What are the two things they are forming? One is zinc hydroxide, which is a solid substance, okay, and ammonium sulfate it is forming. Okay, so just take ZnSO4 plus ammonia solution now. So if it is ammonia solution, like adding ammonia to water, so whenever you add ammonia to water, see ammonia act as a base and water has amphoteric nature, therefore it can used as a here, it will works as an acid here. If it is base, water shows acidic nature and they will form ammonium hydroxide, NH4OH compound is formed. Okay, so this NH4OH upon treating with zinc sulfate, with what? Zinc sulfate, ZnSO4, so it will be forming ZnOH, zinc hydroxide is formed and ammonium sulfate, NH4 twice SO4, like this, NH4 twice SO4 is formed. Okay, that's it. This is one reaction. Now what are the products? Zinc hydroxide, which is a white precipitate, you need to write that. Okay, and ammonium sulfate, which is soluble, that is the aqueous solution. Okay, normal aqueous solution only, because it will be soluble in this solution, that's it. Okay, next reaction with copper sulfate, with what? With copper sulfate. So ammonia reacts with copper sulfate to form a deep blue complex called tetraamine copper 2 sulfate. That is nothing but a blue vitriol we are saying. Okay, so here related to that. Okay, so look at here, blue color compound, how it will be? Blue color, deep blue color is due to presence of Cu plus 2 ion. What is that? Due to presence of this Cu plus 2 ion. Okay, so now how do you write this? How do you write this? See, copper sulfate, CuSO4 is there. To this we are adding ammonium hydroxide, that ammonia only, like ammonia hydroxide it will be represented. Okay, how many moles? 4 moles. So it will be forming here plus 2 oxidation state for copper. Okay, so with respect to that plus 2 you are going to get Cu NH3 4 times. Okay, in this also it will be plus 2 only, and sulfate ion, that is minus 2, SO4 2 minus. Okay, that's it. So this is the product formed here, and along with this, see ammonium now, how many hydrogens are extra here? 1 hydrogen is extra in each ammonia, so that will be reacting with OH and forms water, like H2O will be produced. How many hydrogens? 4 OH groups, 4 hydrogens forms 4 water. Okay, that's it. Those are the products formed. Okay, that's it. So what is the color of this complex? It is a blue color complex. What is that? Blue color complex. Okay, what is the name of that complex? Tetraamine copper 2 sulfate, tetraamine copper 2 sulfate. Okay, just write this reaction and write its color. Okay, very, very important it is. Okay, next. Next, reaction with silver chloride. What is that? Reaction with silver chloride. So silver chloride, AgCl, is a solid substance here. Okay, it's a white solid substance. White solid substance. Just look at here what they are saying. Reaction with silver chloride. It means you just take silver chloride with ammonia. What happens? It will form a complex like Ag, NH3 twice. Okay, and chloride ion. Here chloride ion minus plus here. That's it. This is a complex. Ammonia dissolve the white precipitate of AgCl. It means if you take ammonia, aqueous solution of ammonia, in that if you add AgCl, okay, AgCl is solid substance, okay, white precipitate you can say. So will this whatever the solid AgCl is there, that will get dissolved in ammonia. Why it will be dissolving? Because it reacts with ammonia and form a complex like this. Soluble complex is formed. Okay, this complex is water soluble. That's why we are getting aqueous solution of this complex. Okay, with the water. Okay, that's it. This is what I am saying. The complex formed here is water soluble. That's why you are going to get a soluble complex. So that's why they are saying ammonia dissolves a white precipitate of AgCl, forming a colorless complex. It's a white or colorless complex, this one. So what is the complex name? So diamine, two amines are there, two ammonias are there, that's why diamine silver, oxidation state of silver is 1, diamine silver chloride, that's it. Then next here products, what is the product formed? That's it, diamine silver chloride, okay, and along with that byproduct here we got is water, okay, that's it. This is the thing you need to mention in the exam. Reaction like production of ammonia is over, and chemical reactions of ammonia is also discussed. So what is the method used for production of ammonia? Industrial method is what? Haber's process. Ee Haber's process lo em chestam cheppandi okkasari. In this Haber's process we will be sending N2 and H2, that will be goes to the compressor. In this compressor 1:3 ratio of N2 plus H2 will compressed at 200 to 900 atm pressure, and that compressed gas will be sent into catalytic chamber, okay, catalyst chamber. So in this catalyst chamber we have iron as a catalyst and molybdenum as a promoter, along with this small traces of alumina plus K2O is present, okay. So now this mixture will make conversion of N2H2 to ammonia. So now this whatever the ammonia produced, that gas will be sent into the final chamber, collector. So into this collector along with ammonia some amount of unreacted N2 and H2 will also go in, okay. So now whatever the N2 H2 is went into the collector chamber, that will be again taken back, sent into recycling by using recycling pump. So with the help of recycling pump, whatever the unreacted N2 and H2 is went into the collector, that will be resent and that will be converting fully into ammonia, that's it. This is the complete process of production of ammonia using Haber's process, okay. What are the favorable condition? High pressures, moderate, low temperatures, okay, that's it. Next what are the things here? It's chemical reactions. What are the chemical reactions we have seen? What are the chemical reactions? It's a reaction with copper sulfate, it's reaction with zinc sulfate, it's a reaction with silver chloride, that's it, okay. When it is reacting with zinc sulfate, it is forming a white precipitate, okay. What it is forming? It's forming a white precipitate, that is zinc hydroxide. When it is again along with that ammonium sulfate is formed, okay. Zinc hydroxide and ammonium sulfate is formed. One is white precipitate, other one is soluble. Next, when it is reacting with copper sulfate, it is forming a blue color complex, tetraamine copper 2 sulfate complex is formed, okay. Then next when we react with silver chloride, it is forming like silver chloride is a white precipitate insoluble in water initially, but when we add it to the ammonia solution, yes, here it is soluble, okay. Why it is soluble? Because it forms a complex. What is the formula of complex? AgNH3 twice, close the bracket and write chlorine. So that is nothing but diamine silver 1 complex, silver 1 chloride complex, that's it, okay. These are the things you should write during the exam, okay. So do not worry, just take a white sheet, try to write each answer line by line. So just go through whatever the words I have explaining here, whatever the words coming out of me, just go through that each word. Yes, that word is mentioned, oh that is because of this reaction, okay, this is the product formed, so its product color is blue color, so the complex, the product name is tetraamine copper 2 sulfate. Like that, try to understand the things, do not by heart, guys. I am saying you don't by heart the things, because if you by heart the things at the end of the exam, definitely, I mean most of the students have fear during the exam, they might be having fear or hurry. So due to that reason, they won't get their answer during the exam time, okay. So it won't strike in their mind and they will be losing their marks, okay, or they won't present the answer effectively during the exam. So what I will be suggesting you, just understand these lines, whatever we have discussed till now, understand these lines, therefore it will be more effectively stays in your mind and you can effectively present in the exam also, okay, right. Next thing here is, next question is how nitric acid is manufactured by Ostwald process, okay, right. Let us look into this question also. Yeah, just a minute, I will be taking some water. Yeah. So what they are saying, how nitric acid manufactured by Ostwald process, how does it react with copper, zinc and SC8, okay, and P4, okay. So now what I will suggest you is, whatever the two questions we have discussed till now, please try to learn them, and this question we are going to discuss in the next session. When I will be discussing, this will be discussed in the next session. This is also important question. There is one more question. This one is preparation of nitric acid using Ostwald process, and the next preparation of sulfuric acid using contact process, okay. These are the two important questions we have from this chapter, okay. These two will be discussed in the next session, okay. So until that, you just stay connected with our NEET World YouTube channel, and you can download our app, NEET World app, from our Play Store, okay. This is our app, NEET World. From that you can access this material, okay. Or you can also join our Telegram group. What I am saying, Telegram group, just go to Telegram and search NEET World, or otherwise every detailed information is provided in the description, okay. So using the description details, you can join our Telegram group, okay. So thanks for watching. Stay connected with this NEET World channel for complete preparation of your IPE as well as EEP set. And if you are preparing for NEET and JEE, yes, this is the best channel in complete preparation. You can make it more effective from our side and from your side, okay. So thank you for watching. Stay connected. Thank you.